You can select if you want to create a new project or open some recent one. I will create a new project, so let's click on that button. I can select the location to where I want to save my project files, so browse and creating a new folder for my project. You need to pay attention to that. Quite easily, this project can consume about 20 to 40 gigabytes of your hard drive, and it is mainly because of different cache files that are created during calculations. I will create a new folder, then giving a name to my project. Usually the same name as my folder, some date and project area name. I keep selected Create an empty block, which is simply a good starting point to my project, which takes care of a combination of parameters, settings, which I start to change in a second. I click OK. I can see a full user interface of ContextCapture. If you pay attention to this orange ribbon, then our workflow will be from left to right by completing different steps that are needed to create our final result. As this block 1 is our starting point, an empty block that was automatically created, once this has been selected, I can tune up my additional settings on the right-hand side. In here, I also do move from left to right. Let's pick photos. In here, I can select all photos based on what I want to create my 3D model. A quick recall. All my photos are in one folder. It is also recommended workflow by ContextCapture as long as all those photos are taken with the same camera. I do have about 1300 images. I can copy this folder location. Now, add photos, add entire directory, and pasting that folder path. Of course, you can get the same result by navigating from this dialog as well. All my images will be linked to my project. I can see that my drone's camera sensor and focal length were automatically detected. But if needed, those values can be changed. ContextCapture can let you include different sources, also point clouds. We do not have those at this time, so I will move forward. Service tab gives you a possibility to mark all your ground control points. In this mission, we did not use those, but in later episodes, we do that as well. Let's move forward. On tab Additional Data, I keep default settings, including block type. Tab 3D View currently shows my drone's locations from where my images were taken. No change here is needed. I will go back to my General tab. Now I will create my preliminary model with what I actually position my photos into 3D space. Those preliminary steps ensure that all our photos can be positioned before we move forward to final calculation. This procedure is called aerotriangulation. Once you click on that button, you can select if you want to use your own computer for calculations or use web service. As I currently do not have that web service available, I will continue by selecting the first one. Once clicked, a new dialog opens. For simple workflow, I try to use as much default settings as possible. If those default settings are not working, or you are not satisfied with the result, only then it makes sense to change those. I do keep the default name here and clicking Next. As I have photos in correct geographical coordinates, I want to use photo positioning metadata in both sections. I won't select Use Targets, as those were not used in my drone mission. I will click Next again. Now I can set up some additional parameters, which will be used for my calculations. My first recommendation is that we use default settings here. So, no small talk here. Let's click on Submit. My preliminary calculation starts. Once again, this process is called as aerotriangulation, which shortens as AT and is also used in my block name by default. Each new calculation is also added into my project tree on the left-hand side. Let's wait once this calculation finishes. Of course, it depends on the scale of our model and also available resources, but usually it takes about 5 to 30 minutes. Once this preliminary calculation has finished, you should see a summary which states if everything went well or some problems occurred. You can also check different reports. To see the preliminary 3D model, I do select tab 3D View. I can see that my preliminary calculation is not correct. It is bended around some central point. This is a common issue if you use long, linear mission data. It means that camera's optical parameters were not correctly calculated. It can be fixed very easily. You need to pick some previous project, smaller area, and use optical properties from that project also in this project, as long as you have used the same camera for capture. Import-export is done during this step. Therefore, you need to ensure that everything looks correct in here before moving forward. Import-export can be done from the tab Photos. You just do a right-click on your photo group and you have a section called Import-export Optical Properties. So, I do need to import into this project optical properties from another project. But of course, we do need to have that file first. This file is actually universal, as long as it is made from the dataset that was taken by the same camera. I save my current project, then clicking Open and opening previous project. Once the previous project is opened, I will select the same stage from this project. I can go to my 3D view and see if that project looks alright. Seems so. I do not have any bended situation here, and it is normally because of smaller scale of our project. Now, let's pick photos, and doing a right-click on my photo group and picking Export Optical Properties. I can save this file with an extension of OPT. I click Save, leaving the default name. I do reopen my highway project again. I go back to my block 1 from where we started beforehand, selecting Photos tab and doing a right-click on Photo Group. Picking a Import Optical Properties, let's find our OPT file and open that. I need to confirm that overwrite, and also I do need to repeat my preliminary calculation. Going back to my General tab, clicking Submit Error Triangulation, Process with ContextCapture Engine. I will input a different block name and then clicking Next, doing the same selections as before, and then moving forward. At Settings page, we need to pay attention to some changes that are needed, because we do want to use imported optical properties. All those parameters that follow optical properties and currently hold a value adjust, I will change to keep. I can then select Submit again. Once again, the preliminary calculation starts, and let's simply wait once this is finished. Once this calculation has been finished, we should see some summary if a calculation was successful or not. Also, some statistics are available. But I will move straight to my 3D View tab to check the improvement. I can see that now everything looks alright, and I can move forward with my next calculation. I go back to my General tab. I will move forward with New Reconstruction Stage that can be found from the lower right corner. I can recall also my workflow on the top, which stages I have carried out and what will be the next one. Once I click on to New Reconstruction, I can select in between 3D Reconstruction and Orthophoto. This time I will select 3D option. My project tree on the left-hand side is updated and I can see Reconstruction node. Once again, I have to tune up some settings parameters. Let's pick Spatial Framework. In here, I can select coordinate system. In my case, it will be Estonian coordinate system. I can also change my calculation area, bounding box. It is useful if I want to calculate only some of my full area, or simply edit my boundaries. Smaller area is also calculated faster. In the section Tiling, I can define how many tiles I want to have in terms of separate calculations. I can see that if I do want to calculate all in one tile, I do need to have about 200 GB of free memory in my PC. You can actually check from the Task Manager how much memory your PC has, and also assume how much you can reserve for context capture, because some of your PC memory is also needed by different applications that are running in background. My current PC has 64 gigabytes, so I do need to apply a tiling to be able to calculate my model. For that, I select Mode, Adaptive Tiling. Adaptive tiling is a good choice when your model area is not regular. In that case, the tiling is applied so that they are in different sizes, and those will be also calculated differently in terms of calculation time. Once this is selected, I can input target RAM usage, maximum 64 in my case, but I will keep it as 48 gigabytes. Once I update this value, I can see how many tiles are created. In some cases, it is even good to divide your model into pieces, as after each piece is calculated, you can immediately check if it satisfies your expectations. And if not, you can cancel the calculation process and save some time. But it is also clear that if we minimize the number of tiles, the calculation time is also higher for one tile. I move forward. On the tab Geometric Constraints, I do not define anything this time. Tab Reference Model shows my tiles and also their default names. So let's move on to Processing Settings. In here, I keep all default settings, and probably one of the most important parameters at this stage is geometric precision. Also, I do keep extra as a default value, which should work for most cases. It is sometimes a good idea to use a lighter option. You can get quicker results and then decide if you need to tune up this quality parameter or not. I move back to General tab. I will click on to Submit New Production and selecting Process with Context Capture Engine. And I do have one final dialog in where I can select some settings which are connected with my final production. I keep the default name. At Purpose tab, I can select the main format of my production. I keep it as 3D Mesh, but I can also select Point Cloud or some other format if I want to edit it in another software. I click Next again. In here, I can select the file format. I keep the context capture default format 3MX, but it is possible to select some other formats as well. Once I have selected 3MX format, I can also select Web Ready option, which enables to produce my production as a web executable. Once uploaded to your web server, it can be accessed through a web browser. You just need to know the web link. For example, I have one of our university's building produced as such. You can create multiple exports from different datasets, measure at different dates, and show the construction process quite easily. It is also possible to change texture maps settings. If you need lighter models, this option is important to check. For example, Web Project automatically uses some lighter options. And if you want to share drone models for context only, then you can minimize the texture quality as well. 3MX format also supports level of detail, which simply means that if you are far away from your model, it will be shown in simple form. And if you zoom in, also the details become available. Very nice option to have. In general, as you see, I'm keeping default settings. I will click Next. Once again, I check if my coordinate system is correct. I confirm also my bounding box. Next again. I can change to where the final production will be saved. I keep the default location, which is subfolder in my project directory. And now I can click on to Submit and simply wait once my model has been generated. This will be done tile by tile, and once one tile is calculated, I can also check it straight away. Remember, the calculation time depends on your PC hardware, the size and complexity of your tile, and can be from minutes to hours. As the first tile has been calculated about 2 hours, I can fire up Context Capture Viewer and check if it looks alright. Once a tile opens, I can also use some tools to locate the point, measure a distance, area, or a volume. Finally, our calculation is finished. We can also see how much time it has taken. If I click onto more details, I can see once again how long it took to calculate one specific tile. And as you see, those times are different because of tile's complexity and size. Once the calculation has been finished, you can move forward to 3D view. And in here, you can see the full model, all that 1.3 kilometer long section that we were measuring at the construction site. We can use this model in our later episodes. Once again, I can use tools to locate a point, measure a distance, measure an area, or measure a volume. In our future episodes, we take another look what else we can do with those drone images in terms of different use cases. Let's do comparisons in between two different PCs that we can use to calculate this model. I will open up this same project that has been calculated in another PC. The final result is the same, but the calculation time